Hey, Year 6 scientists, how are you? Just want to talk you through this investigation on exploding bags. Basically, the aim here is to talk you through all of the processes of the experiment and what I'm looking for when you're filling everything in and designing your prac. So this video is intended to be viewed with you maybe working along. You might want to fast forward and go to a section that you're up to, so that will give you a bit of a hand. So basically what we're looking for is investigating, can an irreversible change produce a gas? So an irreversible change means you can't turn it back. So we're talking about a chemical change here. And can we conduct a fair test to find out what will create the largest amount of gas? So this is just a bit of preamble, just a bit of context. The important part here is by mixing baking soda, warm water and vinegar, it will create a gas. And that gas is carbon dioxide gas. So that means a sealed bag can inflate, so it will fill up with the gas, and then it will explode. Now there's a video that I'd recommend that you watch, just so you can have a bit of an idea and a bit of a visual with what the experiment looks like. So the first bit is we're going to brainstorm the list of things that could affect the time it takes for the bag to explode. So when we're filling in this brainstorm, we're thinking of what we call variables, so factors that can affect how long it takes that bag to explode. So I did this with you guys in class today. So one thing that we came up with was the amount of baking soda that's added. So I can say amount of baking soda. Now I don't want to say what's going to make it faster or slower. I just want to say what's going to affect it. Okay, so amount of baking soda. I'm going to change the word amount and I'm going to say mass. Okay, because mass is something that you weigh. And I might even be really scientific and have a unit here. I might say grams. So I could weigh it on a measuring scale, and I could see how much that we're going to use. Okay, but I'll just leave it like that. So what else could affect the time it takes for this bag to explode? You guys also come up with the size of the bag. So if the bag is smaller, then it won't take as much time to fill up, and it will pop more quickly. If it's bigger, it might take up more time. If you think about if you had a massive, I don't know, garbage bag, that would not really even fill up because you wouldn't have enough gas being produced. So I won't go on for too long, but maybe we'll think of a couple more. It could be the amount that the bag is shook or shaken. Probably not great English, but if you watch the video, when they mix the chemicals, they shake it up, and usually that will make the reaction happen a bit more quicker, so it might pop, as opposed to maybe just kind of plopping it in and dropping it on the floor. So I really hate the language that I've used there, but it gives you a bit of an idea about what I'm talking about. Another factor could be the volume of vinegar that's used, because we're mixing vinegar and bicarb soda. They're the two things that will cause the fizz, the carbon dioxide. But also we're adding water too. Another student came up with the temperature of water. So making the water cold, room temperature, or hot, that might actually make a difference as well. Okay. All right. There's lots more things, to be honest. You could probably come up with another few, but I'm going to leave that there for now. So select one of the things from above you'd like to investigate. So I'm going to pick the mass of baking soda. That's going to be my one variable that I'm going to say that's the one that I'm going to test. So what do I want to find out? Okay, so I'd like to find out if the mass of baking soda affects the time taken for the bag to explode. Okay. Now, when you're writing an aim, I'm basically trying to say, if I change this, I want to see the effect on this. And the reason why we're working on the time it takes for the bag to explode is because that is what the investigation is about. Okay. So to find out how to, actually it says it somewhere, hold on. Here we go. Sorry, it was here. That could affect the time it takes for the bag to explode. So that's the thing that we're trying to measure how long that takes. Okay. So these are your variables. So we want to change something. We want to measure something, and we want to keep something the same. So what we're going to change is, or what I'm going to change, you can pick something different, is the amount or the mass of bicarb soda. And I'm going to say grams because I could go 1 spoon, 2 spoon, 3 spoons, something like that. Or I could say, I want to measure, I want to weigh it, okay? That will give you a number. It could be 5 grams, 2 grams, 10 grams, and then you've got a number. That's called quantitative data. That's better than just saying small, medium, large. That's okay, but numbers are usually better. Now, I'm measuring the time taken for the bag to explode. And that time will be measured with a measuring device, and we could say a stopwatch, okay? And usually a stopwatch will measure a time in seconds. Now, if you watch the video, the bag explodes pretty quickly. So I could say that that time is going to be in seconds. And when we write units, we usually write them in brackets, okay? So seconds. I might just format this a little bit so it actually fits in the boxes. Now, what am I going to keep the same? I'm going to keep the other things that I identified in my brainstorm the same, okay? So when I do my tests, I'm going to shake the bag the same amount of times, either once, twice, no times. The size of the bag is going to be the same. I'm going to use the same size bag every single time I test. The volume of vinegar is the same. The temperature of water is the same. There's other variables too. I want you to try and come up with more if you can, okay? So I would write all of those down, okay? So temperature of water, amount of vinegar, and I'll go ... because I'm not going to write them all, but you guys will, okay? And you can see that this formatting is not amazing, but I can change the size of the font, or at least I should be able to. Make it smaller. There we go. Look at that. So I can just change that so it actually fits what's going on. Hopefully. Okay. So now a testable question. So I'm going to summarize my variables into a scientific question. So the format's here. When I change something, what will happen to something? Now, these colored boxes are because we've done them here. You can see that the colors should match up. So when I change the mass of bicarb soda, so I'm just going to add that there. When I change the mass, what will happen to the time taken for the bag to explode, okay? I'll just say the time for the bag to explode, okay? So that's our testable question, okay? When I change this, what will happen to this? A prediction. So now I'm linking that to my testable question. So I'm trying to think, okay, when I change the mass, so I can have a little bit of mass, a medium amount of mass, or a lot of mass, what's going to happen to the time? So this is where you predict, okay? Now, you don't need to start a prediction with I think, because it is obvious that it's what you think, because it's your prediction, okay? So I can say, as the mass of bicarb soda is increased, the time taken for the bag to explode will... Now, I'm probably writing this a little bit scientifically, and maybe the language is a little bit, but this is how we'd write it. As the mass of the bicarb soda is increased, so that means we're adding more, the time taken for the bag to explode will... Now, this is the part that's a bit tricky. I'm going to say decrease, okay? Because if you think about it, a small amount of time means the bag exploded quickly, because that's what I think will happen, okay? So another way to write it, I might just change the language. It might make a bit more sense to you if I do it this way. As the mass of the bicarb soda is increased, the bag will explode more quickly. Now those two sentences mean the same things, but this one you might understand it a little bit more. but this one is the way that I'd prefer you to write it because we're using the words increase and decrease, which are key kind of scientific words. If you can write something like this in year 6, you will cruise through when you're doing practicals, okay? All right, what materials will I need to complete my investigation? Now, you're going to write a materials list for everything that you need, okay? So, and usually do it in dot points. So I need bicarb soda. I need vinegar. Okay, I need hot water. Now, how do I get hot water? Maybe from the tap, or maybe I need a kettle. Okay, so we're thinking, where do I get hot water from? Is there a hot water tap in the lab? These are the kinds of things we want to think of. How am I going to measure out my bicarb soda? I could have measuring cups. Okay. How big should my measuring cups be? Do I need half a cup, quarter of a cup? You know what? There's actually a science instrument that we can use to measure. It's called a measuring cylinder. Okay. How big should the measuring cylinder be? Okay, maybe I need like a spoon. Maybe I want to do spoonfuls. I need plastic bags. How many plastic bags do I need? How many times am I going to do the experiment? Am I going to do it 3 times? Am I going to do it 4 times, 5 times, 6 times? You know what? I might do it 6 times. And I'll tell you why as I'm kind of going down. But I think 6 times might be a good number. What else might I need? Do I need to measure out the vinegar? Do I need the tissues? Now, look, to be honest, there might be more things that you need. There might be less things that you need. To be honest, it's probably going to be more. But I think you've got the idea. I'm not going to do this whole practical for us. I'm just going to kind of guide you in terms of doing it. So the method is a step-by-step, how do I do the investigation? Keep it short, simple steps. Okay? So basically what I'm thinking is I'm going to get my safety gear on, but I don't need to write that. What's the first thing I'm going to do? So you might say, measure 1 spoonful, maybe. Let's just say 1/4 of a cup of baking soda. Okay. Now, I'm just getting that off the top of my head. You might want to actually look at what 1/4 of a cup looks like. Okay. Is that a lot? Is that not very much? You want to pick a reasonable amount. So it's good if you actually have the instruments in front of you so you can kind of see what's going on. Okay. So measure 1/4 of a cup of baking soda. And it might be fill bag with 50 milliliters of water. I'm just making up values here. Fill bag with 50 ml vinegar. Actually, might do warm water. And then I might say, put baking soda into a tissue. Wrap up baking soda in tissue. And if you're thinking why are we putting it in a tissue, that's what happens in the video, because when you put it in the bag and you shake it up, it gives it a bit of time for it to start fizzing. If it happens straight away, the bag's going to explode while you're holding it, and that's probably not good. It's kind of delaying what's happening here. So wrap up the baking soda in a tissue, drop the tissue into the bag and quickly seal it. Shake the bag and drop it onto the floor. Actually, for this, we need to time it. So as soon as the person drops the tissue into the bag, starting the stopwatch, and quickly seal it. That's probably a lot of things for one step, but I think, yeah, it might be doing that. Shake the bag, and you might say starting to stop, like that's person 2, so that's okay. Shake the bag and drop it onto the floor. Stop the timer when the bag explodes. Okay. I'm not going to spend a lot more time thinking about this, and there might be things that I've missed, but I hope that gives you a bit of an idea what we're trying to do for a method, because a method is if I gave it to you, or if you gave your method to your friend, they would know what to do. That's what you want to think about it. You want to think about, if my friend was away, or my lab partner, and I gave them this set of instructions, would they know what to do? If they don't, then you haven't put enough detail in, okay? So things like measure a quarter of a cup. Obviously, you're using the cup. Something I've missed, fill bag with 50 mils of warm water. How am I measuring 50 mils? Okay? So I might even say, measure 50 mils of water using a measuring cylinder and put into a plastic bag. So now the person knows what they're measuring it with, okay? So using the same measuring cylinder. Okay? All right, I think you kind of have an idea. Now, if this is hard, if you're thinking, I don't know what to do, or the step-by-step where writing is a bit difficult, you can supplement that with a labeled diagram or even a picture, okay? You can drop any file in here. It can be a picture file, whatever. So if you have these instructions and you think, this is getting too tricky, you could draw a picture, a scientific diagram that shows what's going on. Usually a scientific diagram is just simple, clear, ruled lines, labeled. It doesn't have colors. It doesn't have shading. It's not three-dimensional. It's just real simple 2D stuff, okay? All right. How do you make sure the investigation is safe? Now, we've got exploding bags. So the bag should not be near another student. So I think that's the key one for me, okay? So it shouldn't be thrown anywhere where other students are, because otherwise they're going to get chemicals on them, okay? There might be some risk of things fizzing before you want them to, stuff getting in your eye, so you might need to wear safety glasses, stuff getting on your clothes, you might need to wear aprons, that kind of thing, all right? But realistically, it's probably just to do with how the bags are actually being thrown once you've shaken them up. Should we do it in a classroom? Probably not, okay? I would say conduct the investigation outside so the lab floor is not messy or wet. Because what happens inside when there's a wet floor in the lab, people are going to slip over, okay? So avoiding slipping and tripping hazards. So instead of just saying, don't do this, I might say, we do it this way because of these reasons. We don't want people to fall over, slip over, okay? All right, now, recording results. This can be done in a number of different ways, and I'm going to show you how I would maybe do it here. And you can follow along with me if you like. Get your Word document. Insert table. And we're just going to do a table. I can change the columns afterwards. It's all good. I just usually do a whatever. So what goes here is the independent variable. Now, what was that? That was the thing that we're going to change. So we're changing the mass of the bicarb soda. And what are we measuring? We're measuring the time taken for the bag to explode. Okay? Now, I've got another column, and I'll show you why I'm doing that in a second. I'm going to merge these cells. You can just highlight and just right-click and go merge. We're going to do trial 1 and trial 2. Okay? Now, usually we do 3 trials. Now, you can do 3 trials if you like. Actually, you know what? We're going to do 3 trials. Why not? Now, if you're thinking, what's a trial is basically a repeat. We're going to do the same thing 3 times. And the reason for that is sometimes there's mistakes that happen. Sometimes there are errors, things that we don't do correct. So if we make a mistake on one, that's really going to impact our result, and our results aren't going to be true. But if we make a bit of a mistake here, but then we do it a bit better the second time, bit better the third time, then the first one where it wasn't so good, it doesn't affect our result as much because we've got two good ones, okay? And we calculate an average, which I'll talk to you about in a bit. Actually, I'm going to go back to 2 trials. I'm going to make it a bit easier on us. Okay. And I'm going to merge that as well. So the mass of the bicarb, I like to actually put shading with my headings because that's just how I roll. Cool. Okay. So the mass of the bicarb soda, you can weigh it if you like. So if I was weighing it, I'm actually going to go back here. I just had a thought. If I'm weighing it, I'm going to use an electronic balance or a set of measuring scales, essentially. Okay, so I'm just going to make up masses. Now I'm just going to say grams, okay? 2 grams, 4 grams, 6 grams, 8 grams. Let's do 5, why not? Let's do 10 grams. Now, look, I don't know if this is correct. I don't know if that's not enough. I'd need to play around with it a little bit, right? But this is just a start. You could do 4, 8, 12, 16. When we're doing the prac, I'll give you a bit more help around this. We can kind of change it up. We can test it. If a group has a good number, it seems to be working well, we'll just kind of change it on the fly. That's absolutely fine, all right? But I'm just going to make up these numbers for now. And basically that's what I'm going to do. That's my results table. And then when I do the experiment, I'll put the times here. So I'll say the time taken in seconds. So maybe the first one will take 8 seconds. The second one will take 11 seconds. Actually, I'll do 10 seconds. When you put 4 grams in, it goes quicker. Maybe it takes 6 seconds, 7 seconds. Now, you can do everything in the stopwatch. You can do 8.25, 10.96. But I would make it easier for yourself, and I would just round off to the nearest whole number. So for example, if I did this one, 6 grams, trial 1, time it, my stopwatch reads 4:32. That means 4 seconds and 32 microseconds. I'm going to go, you know what? I'm going to round down that 32 and just keep it to 4 seconds. If you get 4:78 for the second one, I'm going to say, okay, that number there is bigger than 5, or it's 5 or bigger. So I'm going to round that whole number up to 5 seconds. We'll make it easier for ourselves, all right? And then once you fill that in, you can calculate an average. To calculate an average, it's pretty easy. You just add up the numbers and you divide it by the total number of values for that trial. So for 2 grams, trial 1 is 8, trial 2 is 10. We go 8 plus 10, and then we divide by 2 because there's 2 trials. So that's going to be 9. Well, I did divide 9, sorry. 18 divided by 2 equals 9. So then my average is going to be 9. Okay, so the average of this one would be 6.5, 4.5, and then let's just make up some numbers, 4, 4, 4, 3, 3, 3. So these are our numbers that we're going to work with, okay? So this column is the most important column, so I might just shade that because it's important, and that is important. Actually, we did for our testable question, it was kind of like purple. Like that. Cool. All right. So I'll save that. I'll just call it mass of bicarb soda. That's fine. All right. And then when I have my recording of results, this is going to be the empty table. Okay. So I will upload what have I done here? Oh, that's to make a table in Style. I'm learning as I go. Have I picked the wrong mode? Am I in the teacher mode here? Sorry. No, that's a preview. Files and media. There we go. So you can make your own table in Style. That's probably easier than what I did. So it has the same options as a Word document. But yeah, that's cool. Okay. All right, so we can do that. And we can get out of that, discard changes, and I'll just go files and media. and I'll upload my file, and I've got that here. I can find it. There we go. All right, so I've uploaded that. Now that should be an empty table, but that's okay. All right, so what happened during our investigation? This is describing the results, okay? So based on my numbers, I would say as more bicarb soda was added to the bags, they exploded more quickly. That's pretty simple. You might want to say other things. You might want to talk about how the bags didn't explode very well. Sometimes they let the gas out and were not able to be sealed properly. Basically, to be honest, you can write anything that happened. I want to know what happened. The more you tell me, the better. Okay? So you could keep going and going and going, and I'm down with it. But this is the main thing. I want you to look at the numbers, and I want you to say, when there's more bicarb soda, there is less time for them to explode. So that's what happened. When we added more and more and more, the time went down and down and down. Now, these are pretty kind of perfect-ish results. Pretty good in terms of they're saying the right things. Science isn't perfect. Sometimes the numbers won't tell you the story, okay? Your numbers might be completely different. You might say, we changed the mass, but there wasn't much difference. They just exploded about the same time. And that's fine. That's good. That's a valid result. So uploading is uploading the table again. So I'll just do that again. The graph. Okay, so we're doing a scatter plot graph. I'm going to show you how to do it. Title is going to be, and just copy me here, the effect of mass of bicarb soda on time taken for bag to explode. All right. I can't even do it. Mass of bicarb soda on time taken for a bag to explode. That's not a great title, but I can't write anymore. Basically, the title should have a bit of an idea on what is happening, and I'm linking how much of this we're adding to this. So basically, I'm just taking those two things from our testable question, chucking them in here. Okay. All right. Now X and Y. This one from your table. Actually, I should go back. We're going to put our numbers in from our table into here. Okay. Now this is our, this goes on the Y-axis. Okay. So these numbers here go here. All right. Now I would just tell you that in class. You have to remember that as you get into later years, but for now, just take my word for it. So I'm just going to go Y, and that Y-axis is here. So I'm going to put a title here, and I'll just copy paste. That one goes up the top there. Well, I didn't copy paste properly. See? Wait, it's not working. Okay, I just realized what I've done. I was clicking the wrong thing. So what I wanted to click was this is the Y-axis. So the thing that you're changing, the variable that you're changing, that is the Y-axis. So I need to click the thing that says Y-axis, and I'll just paste that there. Okay, and this is the time taken for bag to explode, and I'll put that on the X-axis. Okay. And I've run out of space, so I'll just get rid of the taken time for bag to explode in seconds. The units are grams and seconds. Okay, 2, 4, 6, 8, 10 is going to be on the Y-axis, which is this one. 2, 4, 6, 8, 10. And the graph changes as you do stuff. Now these numbers, 9, 6.5, 4.5, 4, and 3. 9, and you can see when I do that, it makes a dot. And that dot represents the time taken for the bag to explode, 9 seconds. So see down here, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9. So on the, well, that's covered by this thing here. So on the 9, that lines up with that. Okay, and you can see there's coordinates 9 and 2. So the y-axis here is 2, and you can see the scale of this axis here, it goes 0.51, 1.52. This gives a really good indication of what teachers want student-drawn graphs to look like. The scale is making it so that the graph is full in terms of size. Okay, so that's my graph. There we go. So this is a visual representation or a picture in terms of what we did. And I can add a line to that as well. I don't want a column graph. You might look at that and go, sweet, I love column graphs. Scientists don't usually like column graphs. We prefer these ones or these ones. I'm going to put this in because I want to put the line in. Okay. Now, what does this tell me? That as you progress through science, you'll be able to see something like this and go, yes, I get this. I get what this means. So this to me tells me that when the mass of the bicarb soda is high, so 10 grams, the time for the bag to explode is low. It only goes up to the number 3. Okay, so that gives me high mass, low time to explode. Whereas when I go down here, low mass of bicarb soda, 2 grams, gives me a higher time to explode, so it takes a while. And there's a good trend here. If there's a line and it looks anything close to a line, that's good. It doesn't matter that it has a kink in it. Anything like that is good. If you had 5 random dots, like all over the place, that would be not a good pattern. Okay, but that's a good pattern there. So conclusion, I would say, as the mass of bicarb soda added to the bag increased, the time the bag exploded more quickly. This can be seen by the shape of the graph. And I might even say, when 10 grams was added, the bag took 3 seconds to explode, which was the quickest time recorded. So what this is doing, what this is doing is it's showing the reader, it's showing the person that you know what this means. Your teacher wants to know, can you interpret a graph? Can you tell me what that graph means? And by saying this, it's giving some context to that number. I'm referring to this data point here. I'm saying at 10 grams, it took 3 seconds for the bag to explode. Cool. Was it a fair test? Yes, it was, because we only changed one variable. Which was the mass of bicarb. All other variables were kept the same. And if you're saying what's the other variables, I'm talking about the other stuff that you identified in your brainstorm. So we changed this, but we kept 1, 2, 3, 4 the same. Okay, and you might be able to think of more, and you might want to write those as well. So we had the same volume of vinegar and water each time. The bag was shaken for the same number of shakes, I guess. And what else did we say? The size of the bags was always the same. So you're basically just saying, this is the stuff that I kept the same. If I was to do the experiment again, what would you do differently? Now, you can say anything, but it has to have a reason, all right? Now, here's the trick. You saying, I want to change this because it makes it more fun and enjoyable and exciting, I get that, right? We all want cool, exciting stuff. But if we're putting our scientist hat on, we want to make the experiment better. And better means we get more data, more numbers, more things to look at, more more things to analyze, because scientists are analytical. All right. We want to see, can we answer this question? All right. So what's a change I could make? Most people are just going to say, make it bigger or whatever. All right. We might say, change or alter the container. All right. I'm just trying to think where I'm going with this. Alter the container used instead of a plastic bag, but why would I do that? Yeah, see, I'm not actually enjoying this now. Okay. You might, instead of bags, you might want to do a reaction. Okay. How about this? You could complete the reaction, or how about measure the gas using a balloon? I just remember a video we watched the other day. I think it was like a container and a balloon was over the top, and the gas went into the balloon and it made the balloon go bigger. So maybe doing a balloon, something to do with a balloon, then we could see how much gas is being made. Okay? So that gives you like a different thing to observe. So maybe that's something we could do. We could say, I would video record the practical. And the reason why is you could review the video to get an exact time. Because, you know, if you have a stopwatch, you time it, when it pops, you might have a bit of lag time, that second to, or that fraction of a second to go, oh, stop. Maybe you weren't paying attention and you don't get the correct numbers. And because the bag explodes so quickly, if you don't pay attention, you'll actually miss a fair bit. So if you had a video, right, you could review it and use the timer of the video to get an exact number. Okay. And that makes your numbers better. So I like that example. I'm really proud of myself here. That example is good. That's the kind of thing I want. I should be able to think of more examples than I want, but that's okay. All right, the rest of this is just a bit of a self-review, and then you press handy for marking. Guys, thanks so much. If you've watched this whole video, props to you. If not, then go back and just watch the bits that you need to watch. Thank you very much. Hope you, good luck. Thanks.